We need to create the GitHub repo. It's gonna be public one. I have already created the name for it, which gonna hold the keys. So now we should clone it. And create new branch in which we are going to be working on the boilerplate. Now let's init npm package. Right, we have package in place. So let's install the TypeScript and basic dependencies. So we have TypeScript, rough. Yeah, now let's init TypeScript. By the way, I will be copy-pasting the ready code snippets because it's not going to be very interesting how I'm debugging the configuration of TypeScript or ESLint. So I'm just copy-pasting from the ready to be copied packages. So we have TypeScript already in place. Let's create a very simple application, which is going to be, say, hello world, and a couple npm scripts to build this application. Yeah, it's capable to be built, and it's running. Now let's install Jest to have the test framework installed. Now let's do Jest init. Once again, Jest will generate the default Jest file, and I will replace it with the Jest config from the article I'm going to share in the video description below. So, right, we have Jest in place. Let's create some very basic test to make sure that the Jest framework is running and we can see at least anything in our test. Yep, it does run, everything is alright. So now let's install ESLint. Same goes for the default ESLint config. Yep, npm for Node.js. Let's add ESLint ignore, and the last one is prettier, just to make our code pretty. Same goes with the prettier config, it's copied, and .env to hook up the environment variables and be able to switch environment configurations between development, production, testing. In this tutorial I will be using two environments, default environment and test environment. And let's add the environment service or config service, which gonna operate with .env and gonna be a reading environment. So we're going to have only one environment variable, which is going to be Mongo connection string, and it's for sure should be required, and for now we'll keep it blank. That's it. Now we have the very basic TypeScript application, even with the very small test, which does nothing but it only works, and that's already a lot. Now let's add the Google Cloud Function Framework. To install Google Cloud Functions Framework, we easily just need to add the npm dependency to the function framework, as well as we need to install Express, because Google Function Framework employs the Express types, and obviously we need to add the types from the Express.js, and basically that's all dependencies we need. So now with our application we need to change the hello world to we need to include the functions framework, and all we need to do is to use the Express.js response request and response objects, which are exactly Express.js response and request objects. So now our hello world function gonna send the string hello world into the response object from Express.js, and we need to tell which handler gonna be used. In our case, it's gonna be gcp-functions-ts-mongodb-boilerplate, and it will call the hello world function. In our npm package, we need to specify where the target GCP function is laying, and what source should be used. So let's build it and let's run it. So see, the application is running on port 8080, and it serves the hello world. So now we have the very basic application running. We have application and we have the function framework. Everything is running on localhost and it serves HTTP requests. That's all right. So now we can start adding some logic to it. Let's start by adding the user upsert and user list logic. We will reuse our hello world function to become a user upsert user function, and there we're going to build our logic. So to have any kind of logic, we definitely need a MongoDB connection, we need to make user upsert, and we need the response with the message. So for user upsert, we're gonna need some kind of logic layer, which gonna be user service, and for MongoDB, we're gonna need some kind of user repository. In our case, we don't we are not going to create any kind of repository. We will just use a model for the simplicity. So yeah, definitely we're gonna need Mongo. So Mongo we're going to run in a Docker container. By the way, it's not so easy to run Mongo in Docker, because it's not enough just to run Mongo in container. You have to init it with the user you're going to use for connection and the database. So let's create the init script to create the Mongo user with write permissions to the database we are going to use for the boilerplate. So in our case, it's going to be our project name database. The user password going to be admin, and we will grant read-write permission to the our dummy database. Obviously, now we can update our connection strings in both cases, in the environment file and test environment file. Now we have Mongo running, and obviously we need to install Mongoose to make our Node.js application to communicate with Mongo. So let's create the very simple dummy user schema. Schema generation is a very generic process, so for generating a schema, especially the boilerplate schema, we can use the AI. In my case, I'm using the GitHub Copilot AI. So let's ask AI to build the very generic user schema. Boom, it's magic, fabulous. So that's very generic user schema you can imagine to have in any kind of project. So same goes for the user service. So let's create the user service with so far a very simple function which we're going to just upsert the user. Once again, we are using GitHub Copilot to generate the very generic code from which we can start. So now we have our schema, and now we have our basic upsert user service method to observe the user. Obviously, it's generated by AI, so I'm gonna need to apply some changes to come up to idea how it should look in the end, but still I already have the ready-to-go infrastructure. So now we have MongoDB, which runs in container, or it could be running somewhere else on a dedicated server or on Atlas Cloud, doesn't matter. So we have MongoDB. In our case, it's MongoDB in Docker. And we have the application. And we have a function which running this application. By the application, I mean the user service, which is capable to making user observed and listing the users list. Thing is, that's a function, and we need to connect somehow to the database. And how we can do it? And we are going to use Mongoose because it's Mongo and it's Node.js. So when I've been developing this function, at first I thought that's gonna be a trouble, because if the function gonna be connecting each time to the database, it will take too much time, and you will be spending each time on each call about 2 seconds on connection. So that was something terrifying to me. But it appeared to be that a function is basically application which is running in the container. So the function is not going to be called each time when you make request. No. Function is running in a container. So, knowing that, you know that Mongoose is using a singleton pattern. So once you have connected it, it's connected, and on next call, the application will reuse the very same connection. So when the function gonna be called, it will be slow, but on the next consecutive calls during the container lifetime period, those calls gonna be extremely fast. A few words on the input and output objects cleaning and validation. So definitely we need to add logic to stream DTOs, and for this one we can use that. So now let's find out how we can indeed the MongoDB connection, how we can trigger it. So to init MongoDB connection, we can think about some kind of wrapper or some kind of middleware. We can use it like useDB or visDB. So what it's going to do is going to init the Mongoose database connection, and it's gonna cache it. So if it's connected, it's not going to make any attempt to have a new connection. It will reuse the existing one. So let's try it out, and let's add the list users logic together with the observed user logic. Now we have the visDB wrapper, which can be considered as just a middleware, which just wraps the actual controller. So now I'm going to write another thing, and it's going to be a command executor. So when I've been developing the Google Cloud function, I thought that one function going to be doing like observed user, another one going to be doing list user, so I'm going to have multiple deployments. And it's basically, in most cases, right idea to separate concerns, but not in this case, because if we assume that the Google Cloud function is the application, and basically it is application, it's in some way Express.js application which is running in the container. By the way, Google Cloud Function Framework wraps Express.js server. So we can say that one function can be responsible for the execution of different commands. So I'm about to add another middleware which gonna be a command executor. So command executor in our case is gonna be some kind of router which gonna call controllers not by route but the command which is given as a parameter. Let's create our command executor. I'm copy pasting it from the ready to use package, so it's once again it's another layer of middleware which gets the command from the query param, and having this query param, it executes the expected logic. Would it be upsert user or would it be fetch users? So for this one we're gonna need to have enum of comments and mapping of comments to the specific controller. So upsert user command gonna call the upsert logic. So let's test it. Let's build the application, run it, and call the list of the users. Yes, it's empty. Alright, now we have in place the command which returns the list of users, and we have connection to database, and everything is awesome. Everything is alright. There is one more command to test. It's user upsert, and we can test it using postman because it's gonna be a post call. But let's create a test, because in this way we can start developing in TDD approach. Well, let's refactor the existing logic because it became messy now in the index.ts file, and it's very difficult to maintain and create tests when you have everything piled up in one entity or one file. So we're going to create everything. Recreate everything almost from scratch. So we are getting back to our app.test.ts file with our test skeleton, and now we reuse it and extend it to be used for the our end-to-end test of our logic. So the test is gonna consist of two test cases: upsert user and get users list. I'm creating the test, so it's going to use the database in test, so it's gonna work against the database. Once again, keeping in mind our hack with ongoing connection with Mongo, we are going to use the force quit flag to stop tests once all the test cases has passed, because we have ongoing connection which is not closed, and it will not let test to finish up. So test is very simple. We are basically using controllers. We can use the particular controller with mocking request and response objects, and having the controller function and input, we can expect the output. Alright, we have application running, we have user upsert, we have user list, we have it running on our local host, it works with our MongoDB, it's covered by tests, so it's time to prepare the production build and deploy it on Google Cloud. Starting from the build, we need another build npm run command, which gonna be build production, in which one we are going to use the very same build as we had, but now we just need to copy the package.json and package log.json, because it's gonna be used by the Google Cloud Run function deploy procedure. So we have everything in place, we have everything there. Now let's create the GitHub Actions to build, test and deploy on branch push or main branch push. So let's see what Copilot offers us. So quite old script. So let's recreate it with latest versions. So we are making npm CI to have all dependencies, doing docker compose, doing npm run test. So now we have everything tested. We are running build. Then we are connecting to the GCP, having the GCP credentials JSON in our secrets, setting up the Google Cloud SDK to be able to operate with the Google Cloud, and finally we calling the Google Cloud Functions deploy procedure to deploy the build on the Google Cloud function run container. And that's it. So we can obviously hardcode all variables, but let's make it right and read the configuration variables such as region, such as function name, function entry point from the environment variables and from secrets. That's you're gonna need to do when you're going to use this boilerplate. Now let's push it to our repo and see the GitHub action is running. So we have all our variables and secrets in place. Now we see that Cloud SDK is set up. We see the deploy. Let's take a look on Google Cloud. Yes, it's deploying. The function got its URL. It got its source code, which is our build code, which we built in our build command. Now let's check it. Yes, default command handler is there, and the user list is empty. It's done. Our boilerplate is working. It's connecting to the MongoDB. It's deployed on the Google Cloud. It's already available on my GitHub public account, so you can use it. It was the last video in a cycle of wrapping up Kinsel's videos, and I'm very happy about that. And the next video is gonna be about the new project, and it's going to be awesome. It's gonna be lots of new stuff. It's gonna be lots of new interesting, and I'm very excited about that. See you in the next videos.